Hi everyone, welcome to Siri Tutorials. This is Srinivas. Okay, so today I'm going to do one of the most important and easiest topic for NCRT purpose. Okay, those who are appearing for annual examinations, I'm going to do one of the important topics, that is inverse trigonometric functions. Okay, it is very much helpful to you. I will do two parts in this. In that first I will discuss only the problems. I want to discuss briefly. I will discuss mainly problem oriented, which will be important in a coming examination. Okay, so don't waste the time. Let us go and start. Okay, see this. What is given one? Okay, so before this, I want to say one thing, that so I will update so many topics which will be important for annual examinations. To know those topics, you need to subscribe the channel and press the bell icon. So with that, you will get frequently my updates. Okay, so don't skip and let us start our program. Right? First, inverse trigonometric functions. Okay, till now we know trigonometric functions. Then what about inverse trigonometric functions? Okay, so trigonometric functions, just one example I will say. Sine, it will be from R to closed interval minus 1 comma 1. It is the trigonometric function. Trigonometric function. Okay, it is a trigonometric function. Now I need inverse of this. Okay, so inverse we have seen in functions. If f from a to b is a function, then inverse of that function is f inverse from b to a. Whenever this function is bijective function, this should be bijective function. Okay, so if sine from r to r, if we take like this cannot be bijective function. Now I will restrict this. Okay, how to restrict sine from closed interval minus pi by 2 comma pi by 2 to closed interval minus 1 comma 1. I have restricted this to minus pi by 2 comma pi by 2. Then this will be bijective. Is bijective function. Bijective means you know 1 1 as well as onto, right? Whenever bijective function, f inverse can be defined. That means sine inverse can be defined from closed interval minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2. Okay, so this is domain of sine inverse and this is range of sine inverse. Range also we can call it as principal. We can also call it as principal value branch. So principal value branch we can say. Range or principal value branch. Okay, na? So like this, for all 6 trigonometric functions, we can define domains as well as ranges. Okay, so easy way I will tell how to remember these. First, I will write like this: sine, next cos, next tan, next cot, sec, cosec. Okay, na? In this way I have taken. Here I will write domain as well as next range. Range, or we can say that principal value branch. Simple. Sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, cosec inverse. See, sine inverse domain, closed interval minus 1 comma 1. First I will write only domains, closed interval. This should be clear, not open. Okay, closed interval. Okay. So cos inverse also same, closed interval minus 1 comma 1. We can remember. Tan inverse will be R, cot inverse will be R. Tan inverse, cot inverse, sine inverse, cos inverse. And sec inverse will be R minus of minus 1 comma 1, open interval. Cosec inverse will be R minus of minus 1 comma 1. Easy to remember. First closed interval minus 1 1, closed interval minus 1 1, R, R, R minus of minus 1 1, R minus of minus 1 1. Now range, or we can say principal value branch. Okay, how can we write? First you have this one, closed interval minus pi by 2 comma pi by 2, closed interval 0 comma pi. Yes, we need to remember these two. After that, same method. Here closed, next what we have? Open, minus pi by 2 pi by 2, or 0 pi. Okay. Now sec inverse, see cos inverse. Cos inverse means closed. Cos inverse means closed 0 comma pi minus, here two conditions will arise, 0 pi by 2. Which one we can substitute? Already 0 we have, so pi by 2. Closed interval 0 comma pi minus pi by 2. To find cosec range, see sine. Sine what we have? Closed interval minus pi by 2 comma pi by 2 minus singleton set. What we can write? Here pi by 2 already came, so we can write 0. Okay. So why we need to take means sec means 1 by cos. Okay. So cos 90 should not be 0 because it will become infinity. 1 by 0 will become not defined. Here cosec is nothing but sine. 1 by sine. 1 by sine means 1 by 0 we should not get. That's why I will minus this 0. Okay. I think you got easily understood domains as well as ranges. Okay, na? Right. After that, some questions will be there. Frequently asked questions. I will choose some questions, and before that I will write one condition. What is that property? I will write sine inverse of minus x is equal to sine inverse x minus sine inverse x. Sine inverse of minus x is equal to minus sine inverse x. After sine, tan inverse of minus x is equal to minus tan inverse x. Next, cosec inverse of minus x is equal to minus cosec inverse x. Each and every will have properties. Once I will do some more video to explain all these clearly. Okay. Next, after this, sine, tan, cosec. Next, one more we have cos inverse of minus x is equal to pi minus cos inverse x. Sec inverse of minus x is equal to pi minus sec inverse x. Cot inverse of minus x is equal to pi minus cot inverse x. Okay, we need to remember this to solve first exercise in NCERT. Okay, chalo, let us start first problem in NCERT. So what we'll have, I will give one question. What is that? First question, principal value branch. Principal what is principal value of sine inverse of 1 by root 2? This is the question. Principal value of sine inverse of 1 by root 2 we need to find. Very simple. First, I will write sine inverse of 1 by root 2 is equal to some y. Okay. Whenever sine inverse asked, we need to know about range. What is the range of sine inverse x? At the beginning we did this one. Okay. So minus pi by 2 comma pi by 2. Just keep this aside. Okay. See, that implies I will write it as sine y is equal to 1 by root 2. Just sine y. That is equal to, we can write it as a sine of pi by 4, isn't it? 1 by root 2 is nothing but sine pi by 4. Is it belongs to this one? Here, pi by 4 belongs to closed interval minus pi by 2 comma pi by 2. Yes, that's why this pi by 4 will be the principal value. Okay, so principal value, how much? Principal value is pi by 4 of this function, inverse trigonometric function. Okay, now I'm going to do one more problem. Same, principal value of one more question, cot inverse minus 1 by root 3. Okay, this is the question. So principal value asked means we need to know range. Range of cot inverse. Range of cot inverse is equal to open interval 0 comma pi. We need to remember. Okay. Now solution. How to find solution? Cot inverse 1 minus 1 by root 3 is equal to y. That implies cot y is equal to, we can write it as minus 1 by root 3. Okay. So its value is cot of, just now I said cot inverse k means we need to write like this, pi minus of, means I will write like this, pi minus of, yes, for what value? Pi minus of 1 by root 3. 1 by root 3 means for what value of 1 by root 3 we get for cot? Okay, simple, that is pi by 3. Okay, na? that is equal to cot 3 pi minus 2 pi by 3. Here 2 pi by 3 belongs to open interval 0 comma 5. Yes, 2 pi by 3. How much its value? 2 pi by 3. 2 into 60. 120 degrees that lies in this. That's why this represents principal value. Principal value is equal to 2 pi by 3 of the given function. Similar method, I will do one more problem. Okay. So next, sine inverse of minus 1 by 2. Same principal value we need to find. Okay. Simple sine inverse of minus 1 by 2. That is equal to sine inverse of minus 1 by 2 is equal to y I will take. That implies sin y is equal to minus 1 by 2. That is equal to sine of minus pi by how much? 6. So minus pi by 6 we got. What about range? Range is minus pi by 2 to pi by 2. Yes, this lies in that. Therefore, principal value is minus pi by 6. Next one, I will do one more question. Tan inverse. Tan inverse of minus root 3. This is also same principal value. Principal value we need. So, same tan inverse of minus root 3 is equal to y. I will take tan y is equal to minus root 3. That is nothing but tan of minus pi by 3. Okay, tan of minus pi by 3. So, is it belongs to what is the range of tan? Range of tan close not closed. It is open minus pi by 2 comma pi by 2. Okay, this belongs to that. Minus pi by 3 belongs to open minus pi by 2 comma pi by 2. Therefore, principal value is equal to minus pi by 3. Okay, so like this we can do all the problems, okay, which are based on this. Now I will do one more problem which is frequently asked. Principal value of cos inverse minus 1 by 2. This is the question. Very simple. What is range? Range is closed interval 0 comma pi. We need to write by side. Solution. What will be the solution? So the solution is what is solution? Cos inverse of minus 1 by 2 is equal to y I will take. That implies cos y is equal to minus 1 by 2. Okay, we need to be careful about cos as well as sec as well as cot. Simple, we can write it as cos of pi minus 1 by 2. Where we get? We get at pi by 3. Cos pi by 3 value 1 by 2. So that is equal to cos 2 pi by 3. Yes, 2 pi by 3 belongs to this. 2 pi by 3 belongs to closed interval 0 comma pi. Therefore, principal value is 2 pi by 3 of this function. Easy? Very easy. Just by practicing one or two, you can do all problems in same method. Okay. Now I am going to do one more last problem based on this, which is frequently asked in exam. Okay. This is most important, right? So principal value of cosec inverse minus root 2. This is the question. Okay. Let us see cosec. What is cosec range? Cosec range is closed interval minus pi by 2 comma pi by 2 minus singleton set 0. Okay, na? Cosec means we need to remember sign. Right. Solution. Simple. Cosec inverse of minus root 2 is equal to y. That implies cosec y is equal to minus root 2. That is equal to cosec of minus root 2 when we get pi by 4. Just you need to remember all trigonometric values. Is it belongs to this one? Yes, of course. Minus pi by 4 belongs to closed interval minus pi by 2 comma pi by 2 minus singleton set 0. Therefore, principal value is minus pi by 4. Understood? So these, if you practice very well, it is enough for exam. Whenever the questions asked as principal value of which inverse trigonometric function. Okay. Now I will move on to one more problem which is important in Ncert textbook. Okay. What is that? Find tan inverse of 1 plus cos inverse of minus 1 by 2 plus the sine inverse of minus 1 by 2. This is the question. Okay. Right. Already I told sine inverse of negative. Direct we can write minus sine inverse x. After that tan inverse of minus x. You can write minus tan inverse x. Similarly, cosec inverse of minus x minus cosec inverse x. Why I am saying these means you need to remember these. After that, cos inverse of minus x, sec inverse of minus x, cot inverse of minus x. For all these cases, pi minus of we get. Okay, na? Right. Let us start. Tan inverse of 1. You know trigonometry table. Tan pi by 4 value 1. Tan pi by 4 value 1. Tan inverse of 1 is equal to pi by 4. This is pi by 4. Plus minus we got. What we get? Pi minus cos inverse of 1 by 2. 1 by 2 we get pi by 3 plus minus this one normal minus, that is minus sine inverse of 1 by 2 is nothing but pi by 6, that is equal to pi by 4 plus pi minus pi by 3 minus pi by 6. Okay, so I will try to do in simple method. Of course, if you want, you can do LCM also, but I will do like this: pi by 4 plus pi minus pi by 3 is nothing but 60. Pi by 6 is nothing but 90. So, sorry, pi by 6 nothing but 30. So 60 plus 30 means 90. We can write it as pi by 2. So pi by 4, pi minus pi by 2 value pi by 2. That is equal to LCM is 4, pi plus 2 pi. So answer is 3 pi by 4. That will be the answer. Very easy if we understand the trigonometric values. Okay. In similar method, I will do one more problem. What is that? Cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. We need to find this value. Very simple. Solution: cos inverse 1 by 2. See, cos pi by 3 value 1 by 2. Cos inverse 1 by 2 is nothing but pi by 3 plus 2 into sin inverse 1 by 2 value pi by 6. 2 3s are pi by 3 plus pi by 3, how much? 2 pi by 3. Very simple answer. Okay, na? Right. Don't get confused. Very easy. Now I'm going to do one more problem. Tan inverse of root 3 minus sec inverse of minus 2. This is the question. We need to find the solution. Already I told, whenever sec inverse comes, what we have? Pi minus sec inverse of x. Okay, right. So then what we get? Tan inverse root 3 solution minus of sec inverse of minus x, pi minus sec inverse of 2. So tan inverse of root 3 minus pi, minus into minus plus sec inverse of 2. Tan inverse root 3. Tan inverse root 3 when we get pi by 3 minus pi. Sec inverse of 2 where we get pi by 4. Okay. Sec pi by 4 value 2. No. Wrong. Sec pi by 3 value is correct. Because cos pi by 3 is equal to 1 by 2. Sec pi by 3 is equal to 2. Okay, na? So sec inverse of 2 means pi by 3. Pi by 3 plus pi by 3, how much? 2 pi by 3 minus pi. Okay, LCM will be 3. 2 pi minus 3 pi. So answer is minus pi by 3. Okay, na? So the answer will be minus pi by 3. Okay, so these are very, very important and easiest problems. Okay, now I will move on to one more condition. What is that condition? Properties. Okay, so about properties, just I will explain directly. I won't explain the proofs. Okay, so afterwards in one more video I will explain clearly. Okay, right. So properties. What are properties? First property, sine inverse of 1 by x is equal to cosec inverse x. Similarly, we can write cos inverse of 1 by x is equal to sec inverse x. Tan inverse of 1 by x is equal to cot inverse x. Okay. After that, okay, here only I will write one more. What is that? Sine inverse of minus x is equal to minus sine inverse x. Just now we have written. I don't write once more. After sine, what we get? Tan inverse. After that, cosec inverse. We did know. Next, after that, cos inverse, sec inverse, and cot inverse. For all these special case, what? Pi minus, pi minus, pi minus. Cos inverse x, sec inverse x, cot inverse x. Here what we get? Minus tan inverse x minus cosec inverse x. Okay. Next, what about the remaining? See this. Sine inverse x plus cos inverse x is equal to pi by 2. Next, tan inverse x plus cot inverse x is equal to pi by 2. Sec inverse x plus cosec inverse x is equal to pi by 2. Okay. Now I am going to write one of the important formulas. With these formulas we can do problems in further. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy, as well as tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy. Okay, so these are two most important formulas. Okay, not problems, most important formulas. With these formulas we can do problems, and after that I will move on to one more also. It will also helpful. 2 tan inverse x is equal to sine inverse of 2x by 1 plus x square. 2 tan inverse x is equal to cos inverse of 1 minus x square by 1 plus x square. 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. For all these values of x, restrictions will be there. What are the restrictions? How can we remember easily? I will tell in another video. That is easy to remember all these conditions. Okay, right. So based on these conditions, I will do problems. Okay, I will do some problems. See, first problem, which is important in exam and which is frequently asked. Okay, what is that question? See that. Show that tan inverse 1 by 2, tan inverse 1 by 2 plus tan inverse 2 by 11, tan inverse 2 by 11 is equal to tan inverse 3 by 4. This is the question. tan inverse 1 by 2 plus tan inverse 2 by 11 is equal to tan inverse 3 by 4 we need to prove. Okay, so here this is less than 0, this is less than 1, this is also less than 1. Okay, and then the product will be also less than 1, right? Whatever. Solution: to find this we need to know about one formula, that is tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Understood? So apply tan inverse of, I want to show this one. Okay, I want to show what is the answer. Tan inverse of 3 by 4. Substitute. This is x and this is y. Tan inverse of x plus y divided by 1 minus x into y, that is equal to tan inverse of, for this total value I am going to find. Okay, LCM, what will be LCM? 22, here 11 plus 4 divided by LCM, how much? 22. 22 into 1, 22 minus 2, 22 got cancelled, that is equal to tan inverse of 11 plus 4, 15 divided by 20, 5 threes are 5 fours are. So answer is tan inverse of 3 by 4, what is required. So LHS I have taken, I got RHS. Okay, na? It is very simple. Similarly, one more problem let us do. Okay, what will be another problem in similar method? Similar method, I will do one of the important problems, that is prove that prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse of 31 by 17. Tan inverse of 31 by 17. This is the question, right? I will do this problem. Solution. How to find? We have two formulas. Okay, we have two formulas. First formula is 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. Second formula, same previous one, tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Okay, to find this, first I will find this value, 2 tan inverse 1 by 2. I will consider this as x. Then it is equal to 2 tan inverse x is equal to tan inverse of 2. X means 1 by 2 divided by 1 minus x square. 1 by 2 whole square. X is nothing but this one. Okay, right. 2 cancel. What we get? Tan inverse of 1 by 1 minus 1 by 4. Tan inverse of this is 1 by 3 by 4, that is equal to tan inverse of 4 by 3. Okay, now I will take LHS. What is LHS? 2 tan inverse 1 by 2 plus tan inverse 1 by 7. Okay. What we have to prove? RHS, tan inverse 31 by 17. We have to show that its value is that is equal to tan inverse 31 by 17. I will prove. Okay, na? See this. We have 2 tan inverse x. 2 tan inverse x value. What we have? Tan inverse 4 by 3 plus tan inverse 1 by 7. We have the formula. What is that formula? This one. Substitute here tan inverse of x plus y divided by 1 minus x into y. Okay. Yes, simplify this. Tan inverse of LCM is 21, 7 4s are 28 plus 3 1s are 3 divided by LCM 21. So 21 into 1, 21 minus 4. 21 got cancelled. So that is equal to tan inverse of 28 plus 3, 31 divided by 17. As usual, we got RHS. So its answer is this one. Okay, na? Easy, I think. You did easily. Okay. So this is about first part. In next class, I will do simplifications as well as most important problems, which are example problems which will be frequently asked in annual exam. Okay, I think you understood. If you have any doubts or if you have any negatives about my teaching, just comment me in my comment box. Okay, so the persons who are not subscribed, please subscribe my channel. Okay, thank you very much. I will do some more videos with your support. Thank you very much.